Scientists will tell you that their project has been one of constant advancement from ignorance to knowledge. But in another sense, you could look at the march of science in exactly the opposite direction, from absolute certainty from the early scientists to complete befuddlement today, through this guy with the theory of relativity to this guy, Heisenberg, with his uncertainty principle. So let's take a look at sort of some steps along that historical path from where it all started, when the philosophers and the physicists were the same people. Basically a bunch of old Greeks sitting around the agora debating stuff without any instruments to examine the real world with. They just talked about it. Some of them were so annoying, like Socrates, that they made him drink poison. Socrates' chronicler came up with this rather depressing view of how much we could know about reality. This is Plato's cave, where we're all sitting here tied with our heads forced forward to examine the wall on which the shadows of reality are being projected from the ideal world that is reality. And that's all we could know, according to Plato. They were all a little bit humble about it, in fact. Democritus was the first Greek to use the word atom. He said the first principles of the universe are atoms and empty space, and everything else is merely thought to exist. So how's that make you feel? And there it sat for more than 2 millennia as the Western world went through a series of dark ages, and really not much progress was made in the scientific area. But it all picked up speed again in the 18th century. Here's John Dalton, the next guy to use the word atoms, and he decided that they were kind of like billiard balls, indivisible. They cannot be created or destroyed once they're on the table anyway. They're all the same in a given element, and they are all different in different elements, and they don't have any in common. And of course, all 4 of these things have been proven to be absolutely untrue by subsequent scientists. So good start, John. Next up was J.J. Thomson, who, a Cambridge fellow, who suggested for the first time that one of the fundamental units, that there were fundamental units down below the atomic level. In fact, the electron was 1,000th the size of an atom. He proposed this plum pudding model in 1904, where a positively charged pudding was full of all these negatively charged electrons. That's about all he knew about it at the time, but it was a start on a model that advanced massively over the next several years. Meanwhile, though, while many were examining the atom, Einstein was thinking big. And in his Annus Mirabilis of 1905, published 4 earth-shaking papers, one of which proposed that light, which everybody thought of as waves, were actually photon particles. And then he, of course, tied together energy and mass in this famous equation that everybody, even the non-physicist among us, knows. But he proposed the special theory of relativity that year too, which suggested that anyone's view is relative to their motion through space, and that therefore there is no absolute view. Also kind of depressing for physicists. This guy was a chemist. This is Rutherford, who thought, well, let's fire some particles at gold foil and see what happens. And when he found out that some went through, some bounced straight back, and many scintillated off at various angles, decided that, in fact, this atom must be mostly empty space, with these electrons flying around and reflecting things off of it, but at bizarre angles. And in fact, he then proposed the planetary model, which is commonly assumed today to still be science's view, but it's not, where a positively charged nucleus at the center had all of these negatively charged tiny electrons orbiting around it, but it was mostly empty space in there. How empty? Physicists now think that the hydrogen atom is 99.99999999996% empty. So how's that make you feel? Next step up was Niels Bohr, Danish chap who at least thought, well, these electrons must have fixed orbits, and when they change their orbit and fall inward, what's emitted is a quantum of energy, and that therefore that's the beginning of the quantum theory of reality. We've all heard about it, don't understand a bit. Thanks to this guy, Mr. Heisenberg. You are probably here, but who knows? Now, it's not just quite that bad. You can't really know the velocity and position of an electron or any subatomic particle with the precision at the same time. That's all he was really saying with the uncertainty principle, but pretty uncertain. What that yields is this version of the atom, the electron cloud model from Schrodinger, who said that all we can know is probabilistically where these protons and electrons are. We can't really position them perfectly. That created kind of this blurry picture of reality where everything's moving, as Einstein said, and relative, and therefore we can't really state anything with certainty about the subatomic world. That kind of got Schrodinger angry, and he proposed, okay, we're off the hook because the physical world is a cat in a box, for example. He's living in there with a decaying atom. The decaying of that atom could happen at any time, we don't know it. So the cat definitely could be dead or definitely could be alive, and he's kind of both right now. We just don't know. But his main point here was that the macroatomic world is somewhat knowable, the subatomic world maybe not so much. But a fascinating thought experiment. That led Heisenberg to say this: only a few know how much one must know to know how little one knows. So in a sense, these physicists are diabolical fiends. Heisenberg the worst of them all. And look where science is, after all. So I think really you could get all depressed about this, or you could do what Democritus did. He was called the laughing philosopher. And of course, Einstein had a great sense of humor. Democritus said, of truth we know nothing, for truth is in a well. So if you promise to read them with a big smile on your face, I'll share with you the 3 books I read to research this report. If you're going to scowl about it, you may not. Thank you.
And thank you, Tom, for an elevated, highly philosophical, highly intellectual speech that was well rehearsed, well researched, excuse me. The purpose of his Pathways presentation, Mastery Number 4, was to present a well-organized, well-delivered, following content with style speech. And you did that A+++. He was supposed to use all our keynotes, our ingenious steps that we've learned in the old method with the 10 modules of clarity and vocal variety and eye contact and gestures and audience engagement. And my first good, or could be better, were your slides. They were simple, they were to the point, they had great visuals that you researched carefully, and you moved them beautifully. One thing that I would mention as a suggestion is, and you couldn't do it here, is you use your hands behind your back as a method of control or thing, and then you point it this way very gently. And that's great, but I'd like to see more of those hands, because one of the most excellent parts of your speech were your hand gestures that talked about the philosophers and wound them together. And your smile was one of the other things that was the best. With this intellectual a presentation, to smile about the content, it is kind of overwhelming to me. If you made these complex concepts about philosophy that I have never even had in college, much less read about, very, very simple. And you added humor to your presentation extremely well, especially when you talk about how spacey we were. That was ingenious. And the other slide I loved so much is, you're probably here, you know, with that cartoon. So you emphasized in the speech how little we all know about these philosophers. And I am glad for the scientists that you are sharing with us and keeping very simple this 7-minute speech. And you asked me about timing because you said before the speech we talked, he had 10 minutes he had to get to 6, but you hit it at 7:20. So congratulations. I'm done.